Hey yo, what's up, YouTube? It's your boy JOSHABRAHAM. If I remember, my last time I did biochemical kinetics, the stupid ass ChatGPT made an image, so I can't use this chat anymore. Followed by it. What? Oh. What? Am I that stupid not to understand what to click? Well, it's time to start with the timers. Yeah. Make sure you set a timer for 30 minutes. For the following question, only consider reversible elementary reaction of an integer reaction order. Okay. Write down the general expression for the differential rate laws of zeroth, first, and second order reaction and give the units of corresponding rate constants. State the integrated rate laws and formulas for half times. For the reaction of second order, assume the two different cases of COA and COB. Uh-huh. General differential rate laws, units, integrated rate laws, and half. Oh damn! I can see deep sea cooking. General differential rate laws. Zeroth order reaction, A to products. Differential rate laws. D of A by D of T equals minus K. What would T be? It's time. I guess time. Integrated rate law. Half-life order. First. It's pretty different. Okay. Second order reaction, case 1, A plus A product second order with respect to A. dc by kg, okay. These are differential rate laws, okay. Is it same? Case 2, a plus b, yeah, okay. K2, these are the times where I'm pretty confused on. What's part B? Which characteristic chemical physical reaction proceeds always via first order kinetics? Radioactive decay, unimolecular rearrangement, or decomposition. Some enzyme catalyzed reaction under certain conditions. Why first order? Rate depends only on the concentration of a single reactant. Rate depends only on the concentration of a single reactant, okay? That's first order. T terminus technicus for this special case of reaction kinetics. Songs are so bad. Nishan J7J. Cracker, hey yo, what's up, man? How you doing? Appreciate to Nishan for checking out the stream. So, yep, I was doing my assignment, and I'm pretty. That's the answer. Okay, that's the answer. Okay. Assume the reaction. Nothing, man. Just checking you out. I appreciate that, brother. I really appreciate that. Yeah. Trivandrum slang പോരട്ടെ. റെഡിയാവും കുറച്ച് വെയിറ്റ് ചെയ്ത്. Just wait, brother. It's gonna come back. It's all gonna come back. Full circle. Assume the reaction A plus B equals C proceeds through second order, first order for A and first order for B. What would happen if what are these? Is it the concentration? I think it's concentration, yeah. Give the terminus technicus for this special case of reaction kinetics. When B is large excess, its concentration barely changes. Rate law simplifies as where K equals KB0. This is a pseudo first order kinetics. What did DeepSeek has to say? Pseudo first order rate constant. Oh, okay. നാട്ടിൽ വന്നിട്ട് കൂടാം പിന്നല്ല. When I get back to India, my roots, it's gonna be amazing. Just first I just need to make sure I pass all the subjects. Then we're gonna get back, brother. It's gonna be amazing. In 1828, Friedrich Wöhlher succeeded in synthesizing urea from ammonium cyanide. This synthesis opened the field of biochemistry as the first time substance previously known only from living organisms could be artificially produced from inanimate matter. The kinetic evaluation for this reaction yields the data presented in the table 1. T per H. Temperature? Or temperature per hour? Reaction order and reaction constant for this reaction via graphical regression line evaluation using spreadsheet program example Excel. Proof of zeroth first and second order. In your upload, you must show the graphical evaluation of all 3 reaction orders. How long it will take... Oh, get the fuck out of here, bro. How long it will take 90% of the initially 0.2 moles of ammonium cyanide. Ammonium cyanide. I think that's ammonium cyanide. B. This would be B. Half-life of ammonium cyanide. Would the half-life of NH4 change if its initial constant? Okay, determine the reaction order and rate constant through graphs. Make 3 plots. Observation. Do we get 0.2 moles? Yeah. We also got 0.2 moles. 63.7 hours. Do we got 63.7 hours? Nope. You did not do it. Okay. I respect that. First, let me read all the questions. Come on. I got 20 minutes. Okay. 2 compounds A and B reacting to yield product C according to the following reaction equation: A plus B gives C. From a series of experiments, the initial reaction rates were determined. Results to see table 2. Okay. We got 2 tables? Calculate / determine the reaction order of the reactant A and B. Each reactant has an individual reaction order. Determine the total reaction order of the reaction. State the rate law for this reaction using correct reaction orders. Calculate the rate constant of this reaction. Calculate the reaction rate for the case. Okay. What did you do? What did you do? Is it 31? 30. 30. Where's 30? Oh, where's 30, bro? 30, okay. We use the methods of initial rates. The general rate law is K equals C A C D. Determine the reaction order M and M. Find M order with respect to A. Compare experiments. See if B is constant. Experiment 1, experiment 2 is constant. Find N order with respect to B. Compare experiments where CFA is constant. Yeah, I do remember this, okay. Where's my digital paper? Behold, digital paper. This is my Bible. This will be known as Josh Bible. Mr. Abraham's Bible. It's so fucking dirty, bro. So, example 30. What? Yep. Something like that. We can see that here. Yeah. We got 3 by 2. That's 3 by 2. Okay. Then, example 31. Did I just not? Okay, there we go. What's 31? The reaction order does not necessarily have to adopt integer values. And consider the following example. A gas decomposes with the reaction of order 7 by 5. After 1 hour, 92% of the gas reacted. Calculate the rate constant and state its correct unit in SI units, assuming an initial pressure of 1 atm and a temperature of 25 degrees Celsius. What did you do? That's the last one. The age of ancient wooden fragment was determined using radiocarbon dating. The fragment shows an activity of 7 counts minute gram. Okay. Whereas a fresh wooden sample has an activity of 18.4 counts minute gram. Note that half-life of carbon-14 is 5,770 years. Yeah, that's short. And that over roughly the past 100 years, a 10% increase in the level of atmospheric C14 occurrence due to nuclear explosions. Calculate the age of ancient wooden fragment. Okay. Oh, wait. They gave me a formula sheet. Wait. We got some formula sheets going on. Oh, come on. So, zeroth order rate law, unit of K, integrated rate laws, linearized rate laws, half-life. Okay. I got the formulas. So we got that. How do I start? Before we start with the answers, I need to know what are these rate order OR, DER, and the rate laws. I'm not remembering. What? So Nishant, if you don't mind, I don't know if you're still here, but I'm gonna refresh the chat because there's something's up in the right side of the screen. I believe you don't mind. The reaction rate tells you how fast a reactant is disappearing or a product is forming. For a reactant A, rate is reactant A. So on the A is on the left side. So this is the concentration of A, I believe. Uh-huh. So concentration of A or change in concentration of A with respect to change in time. Derivatives. Derivatives. Rate law. Rate law expresses the reaction rate in terms of concentration of reactants. K rate constant depends on temperature, catalyst, etc., etc. M and M reaction orders with respect to A and B. Important. Reaction order is not always the same as stoichiometric coefficient. Only for elementary reactions they are same. Okay. Reaction order. Zeroth order rate does not depend on A at all. First order rate is directly proportional to A. Second order rate depends on the square of A or A. Okay. So can I get an example? De- Depending on different order. What? Depending on the rate order, the unit of rate constant of changes. Interesting. Rate depends on nothing. Constant. Linear. Okay, this part, zeroth order rate depends only on the constant. First order linearly on A. So, yeah, depends on change in A, the reactant, quadratically. Integrated rate loss. These shows how concentration change over time. Zeroth order. Wait. What happened? Half life. Time it takes to half of A to react. Well, for zeroth and half life depends on A0. For first order, it doesn't. So A0 initial concentration, I believe. Now one of my question was, could you give me examples of zeroth, first, and second? Definition: rate is independent of the reaction concentration. Rate log K. Catalytic surface reaction when surface is saturated. Photochemical reaction under intense light. Okay, so these are reactions where, the concentration of reactant does not matter. Like, so that means uh, for the reaction to happen, something else other than reactant is required. Rate depends linearly on the concentration of one reactant. Radioactive decay. The decay rate depends only on the number of radioactive nuclei left. Okay. Unimolecular decomposition. Rate depends only on. Okay. Second order. Rate depends on the square of one's reactant or on two different reactants. A plus A produce second order in A. Rate depends on NO square. Okay. A plus B. So the zeroth. Mm, to happen, and the first and second first order. Compound interaction of two I don't think it's fully right. Oh, it's okay. That's a good way to think about it. In simple terms, the reaction rate doesn't care about how it controlled by something external like catalyst. Okay, I was thinking if catalyst was involved, catalyst, surface, or light intensity, adding more reactant doesn't speed it up. First order reaction rate depends on the amount of one reactant. It's like a molecule and decay or transform its own. Think radioactive decay, molecule that decomposes spontaneously. Second order reaction rate depends on the two molecules colliding, either two of the same type or one of each type. The more molecules there are, the higher the chance they meet and react. Okay, so that's basically zeroth, first, second. I'll be right back. I need to get my energy juice. Back, son! Oh! I even closed the windows. Why is it so... Why am I shivering? Where's battery, bro? Okay. 89? Again, I wasted time. Ugh! Stupid. So this model actually works well when you're predicting kinetics without memorizing the formulas. Okay, I don't care. What's my next question? So those are zeroed. Write down the general expression for differential rate loss. State the integrated rate loss and formulas for the half times. Wait. Let's set a timer for 30 minutes. Differential rate law. So dfa by dft equals minus k. The explanation: the rate of the reaction is constant and does not depend on A. This happens when an external factor like saturated catalyst, surface, or light controls the rate. Unit of K, mole per liter second, because A changes per unit time. Mole per liter per second. Okay. The negative sign shows decreasing amount of A, right? Yeah. Integrated rate law. Concentration of A at T equals initial concentration minus K times T. Over time, A decreases linearly because the rate is constant. At T equals 0, AT equals A0. Okay. So that's the integrated rate law for zeroth order. Half-life. T half explanation: since the rate is constant, half-life depends on the initial concentration, more starting material, longer time to reach half. Yeah, but um, I mean, it makes sense to divide it. Initial concentration divided by 2 times the rate constant. You know what? Let me just confirm this. Uh, I mean, it's Gemini. That's also answered by AI, so yeah, looks like that's the correct answer. Yeah. First order reaction A to products, differential rate is minus K into again, we're not talking about initial concentration. It's just explanation: the rate is proportional to the concentration of A. If there's more A, more molecules are available to react per unit time. Classic for Unimolecular decomposition or radioactive decay. Units of K per second. Per time, because it's multiplied by concentration to get rate. Integrated rate law is explanation. The concentration decreases exponentially over time. Why does it decrease exponentially? Yeah, when there's more A, the faster it's gonna dissociate, or yeah. Uh-huh. Half-life. Oh, log of 2 by K. For first order, half-life does not depend on A because the fraction of molecules that react per unit time is constant. The fraction of molecules that react per unit time is constant. I did not get that. Half-life does not depend on A. There are two possibilities, okay? Mm-hmm. That's just the first part. What's this? Speaker. Oh, come on, bro. So second order reaction to a product's differential equation rate law minus K concentration rate depends on the probability of two A molecules colliding, so it's proportional to A square. Okay. Integrated rate law 1 by A T equals A0 plus K by. As time increases, 1 by A grows linearly with time. This reflects the concentration drops more slowly over time as fewer molecules are available to collide. Makes sense. Half-life. Okay, I need to learn this ASAP and write this. A plus B products minus Y is only A. Rate depends on both reactions. More A, more B, more collision, faster reaction, units of K. Integrated rate law. Okay, I got the zeroth and first order. Second order, I got the this one, but I still haven't gotten this one. I'm just a bit confused on this part. I'll be right back. I just need to, you know, you know. Back. First order reaction rate, dFA by dt equals, it's just minus k. This is minus k times concentration. T half is A0 by 2k. A0 e raised to minus kt. If we integrate this, T0 over time, A decreases linearly, but rate is constant. Bio Do I have the downloaded sequence analysis assignment? Nope. Design the function in a general way that is sequences, gap penalties, and scoring matrix should be supplied as arguments. The function should not print any output, should only return the final score as well as the corresponding alignments. The highest score can lead to multiple alignments. The main program should then print the score and alignment to standard output. The command line interface should be, yeah. For reading score matrix, you can use reading, okay. Just copy the function into the program or import it. An exemplar invocation can be seen as below. Test your program following 3 pairs of, for each pair, choose at least 2 different blossom parameters. Which characteristic chemical physical reaction proceeds always through first order kinetics? Which characteristic chemical physical reaction? Decay, right? Radioactive decay, unimolecular dissociation type sheet. So 30 minutes, push-up time. That's just a slightly different notation, but it's the same idea. Stoichiometric coefficient of A in the reaction. For general products, the rate is always expressed in the terms how fast each reactant disappears relative to its stoichiometric coefficient. For a zero total reaction, the rate doesn't depend on A or B, so so I can rewrite. Yeah, give me the equations as my tutorin gave me, as that seems more formula. Push-ups. I did the clap. Example 29. Proceeds the reaction based on external factors. I say we start a timer for 30 minutes. Zeroth order reaction first Concentration decreases exponentially. Mm-hmm. So D of C, concentration of A divided by T K. This would be differential rate law. Integrated rate law equals C. Concentration decreases. The reaction rate is independent of A. Integrated rate law. Integrated rate law. Concentration of A equals concentration of A0 plus now minus kVA. Concentration decreases linearly with time. What made this like linearly with time? I guess What made it say decreases linearly with time? Half-life, half-life. dF equals concentration of A0 divided by half-life depends on the concentration initial concentration. Equation mx plus b. Relating to oh, you took time as concentration at y equals b plus mx. Half-life explanation. Half-life depends on the initial concentration and stoichiometry. Now it's time for dude, I should tie my hair or do something. This is so annoying. First order reaction. What is first order reaction? Differential rate law. reaction rate, reaction proceeds, or convert themselves. Rate proportional to A by proportional to concentration of A. Integrated rate law. Differential rate law. What this is? Wait. Integrated rate law. Daniel Carnero. Hello. What's up, brother? How you doing? It's been a while. It's been a while. What's that writing? Integrated rate law. How you doing? I apologize for latency. Yep, I can play 15 minutes of Undertale. That seems a good idea. Let me plug in my SSD because all the games are in SSD. Come on. I believe the SSD is in. Gonna turn off Stage Manager. Yeah, that's in. So dude, I forgot where I was in Undertale. Like last part, it was a boss fight or something. Yeah. I do. Yeah, I got it. It was a spider. I could not defeat the spider. I don't know how it's gonna be today. Most likely, I could not defeat the spider because that thing was hard. Not even kidding. Let's see, set timer for 15 minutes. Should I get the... Last time you were fighting against the Muffet. I believe Muffet is the spider? Right? I think it's the spider, right? What just happened? Continue. I can't just die. Let me go, please. I heard that they're awfully stingy with their money. Oh, you think your taste is too refined for your pastries, don't you, dearie? I discourage with that notion. I think your taste is exactly what this next batch needs. Batch? You call your offsprings batch? You know what? I'm gonna fight. Don't look so blue, my dearie. You think purple is a better look on you? Should I try defeating this? Cause I don't know if there's any other option. All the spiders clap along the music. She gives up after a while. If I keep on attacking, is that how it is? Please give up. Should I press Z? What's with the Z? Oh. What's this? That was cool. The person who warned us about you, okay. Oh no. Not even close. No, I'm dead. If you attack in the middle, you deal more damage. I know, but... I'm dead. Items. Okay. Come on. Come on, boy. Can't just skip this cutscene. Just get me to the fight. I think the best option for you is keep attacking because you have no items. Yeah, I mean, if this spider stops at half-life, I'm glad because I don't want to kill these. I'm a man of peace. Ow. Stop with the pet. Oh. I'm already at half. No. Please stop attacking. I don't. Oh wait. $31. Stay determined. Yes, I will. You need to dodge her attacks better. You should move more. I know. But it's my keyboard. I don't know. My skills are not that good, I guess. Wow. What? No way. I missed that. 15 minutes? No, I don't think so. 30 minutes. Okay, that's from... I pressed enter. Please. Looks like I'm gonna die. Don't kill me, please. Whew. Okay. Why did I do that? Three minutes. One more try. You know, I can witness my I can see that I suck at gaming. There's a secret boss in this area. What? There's more boss? Oh, looks so blue, my dear. Dear. That was stupid. That was so stupid. already at half, but... Double entertain. Hey, double entertain here. Hey, yo, appreciate double entertain for checking out the stream. Oh. Wait. Wait, don't do this, bro. Try to aim in the center while attacking. Yeah, I think attacking towards the center, that's more easier, but dodging is pretty hard. I don't think it's hard for a normal player, but for me it's pretty hard, bro. My skills are down here. One more try. I got 1 minute. I'm just gonna close the timer. I pressed enter. Bro. That should be 60. Dude, you kidding me? You're kidding me, fam. 58, 60. That should be 60. God damn it. That was stupid. Wait, I can't read the chat right now. Just a minute. Wait. Oh, whoa. Okay, that was good. Let me start with poem sorta for Gaster. I think you should have at least 2 items. The main, unbound by space and time, his fan theories are in their prime. Meet him once with the countless tries just to lose him in your eyes. Bro, what is double entertain talking? What are you even saying? Might? It's 60, come on. Please. 61, okay. It's strange, but I saw. Okay. 50, come on. We can hit a 50. Oh. It's not done. Not done yet. Please. Okay. Give up. Just give up. Mercy? Spare? You haven't heard? Okay. That was stupid. Cannot end now. Practice. Stay determined. Yes, brother. Stay determined. Yeah, that's 15 minutes. Can I save? Save. Well, that was interesting. Daniel Carnero. I'm sorry I couldn't beat it on time. Do you remember when does this spider give up? For context, Gaster is the most mysterious character in all of Undertale and isn't bounded by timelines. Meeting him is very rare, although you cannot interact with him. Ah, Gaster. I don't think I came across that character. Well, I how did you know about this Gaster? I guess I don't know. The spider gives up after like a 20 attacks or something. I gotta keep improving my dodging skills. These. I need to make sure. Encountering Gaster is an extremely rare Easter egg. Okay. You know, you guys talk a lot about Gaster. Let me see what this character is. Oh shit. No, I haven't seen this. I haven't seen this thing. Oh, does not have any confirmed appearance in the game. So how did you find about it's like a fan made character? I'll be right back. This encounter is very rare, only showing on specific fun values. Okay. The more you know, I guess. So where was I last time? Integrated rate law for second order reaction. In the waterfall, there's a very low chance that a gray door will appear. If you enter that door, a mysterious character will be there. This character is theorized to be W.D. Gaster. Waterfall. Where exactly is this waterfall? Do you think I have came across the waterfall? I believe because I do remember a waterfall. Exponential concentration decreases exponentially. Mm-hmm. Gaster is mentioned throughout the game by his followers, who are also an Easter egg. Hmm. I haven't met. I mean, I still haven't met the king yet, so I need to. I have to witness a lot of characters. Concentration of A equals concentration of A0 multiplied by e raised to minus k and V into T. Concentration decreases exponentially. It's where you fought Undyne and the Mad Dummy. Oh, okay, okay. Now I'm starting to remember the place. And I think I could go back if I want. Uh-huh. You know what? I should check that out. I should check that place out if there's any sort of Easter eggs. Concentration decreases exponentially. Half-life. I think I'll finish all this. For a first order reaction, the integrated rate law is the equation as an exponential function. Decay is multiplicative, not subtractive. Mm, uh, concentration of A0 is high, uh, which means fast decomposition or rate is low. Slow decomposition makes sense. I gotta go. Have a good day. Hey, yo, Daniel Carnera, I gotta say, I respect you for checking out the stream. And it's been a while since I tried Undertale, so I got reminded how bad I was. Well, appreciate for checking out the stream. Oh, wait. I was also looking at one thing. Ich will da double entertain. Where did this guy also leave? Flow decomposition. Fast drop in the beginning, slower drop later. Okay, so it's like gonna go like that. Yeah, it's gonna go like this. Okay. Half-life. T 1/2 equals K. Half-life depend on the concentration scaled by stoichiometry. Now, time for the second order. Second order. Case 1. The second one is case 2. So, what was the difference between second order and first order? Mm, Rate difference. First order rate depends on one reactant only. Rate depends on two molecules colliding. I put my chicken outside the fridge. Let me go just go check it out. Like, is it still frozen or not? Just got checked it, and yeah, it is it is half frozen now. Mm, yeah, I believe Daniel Carnero and Double Entertain are not in the comments or the chat. So I could just refresh the chat, right? Refresh. Mm-hmm. So case 1, case 2 for second order reaction. Case 1, same reactant colliding with itself. Yeah. That would be same as, no, not same as that, but did I write the unit? No. Unit for first order is 1/2. So this is differential rate law would be minus 1/VA d of Ca, no, derivative of concentration of A divided by dt equals K times concentration of A square. The chance of reaction increase with square of concentration because two rate increases with as 2A are required to case 2 differential equation minus 1 by, wait, you know what, I think I have a good idea. By V wait is Y is okay. Stoichiometric. Stoichiometric constant of what? What? Why can't I go here? The general proper form always includes the A. Why? For general differential law is okay. Since it's elementary reaction with order 1. Mm-hmm. Is that how it is? Mm-hmm. I don't know. For me, it's. Mm-hmm. 1 by VA. df concentration of A divided by dt equals minus 1 by VB. df concentration of B by dt equals KCAO. Is it an initial? I keep on forgetting. No, it's just normal. Rate depends on both reactant concentrations. Mm-hmm. Integrated rate law. If A equals 0, 1 by CA equals 1 by integrated rate law. One by concentration of A equals 1 by initial concentration of A plus it's the same. So I believe. Wait. Hmm. Formula is more complex. What do you mean more complex? What the? For this equation, C V0 does it matter if it's C? I don't think it matters. Yes, it matters because sign flips. No. The standard integrated second order. This is the for most textbooks use is positive if B is greater than A. Okay. If A then turn becomes negative, which is fine. Then the left side also becomes negative. Then the right hand side changes sign because so my tutorin gave No, not just that, bro. Okay, I'll just copy. Okay. No, the B0 and divided by their own initial concentration. Yeah, this is. Oh. Now, what are the conditions for this formula? Meg, should A or B have higher concentration? Oh, it's still do. Okay. So writing. Okay. Devoto did. Hi Josh. Hey yo, what's up? I appreciate for checking out the stream. Devoto did. Hell yeah. Uh huh. This is not what I was going for. Yep. So you know what? I'm gonna send this to my. Not the iPad. No. Okay. Okay. I see what you did there. Mm-hmm. Uh huh. Liter mole per second. Linearized rate loss integrated. Was that part of the question? No, I don't think so. Oh, what is this actually? C, no. Concentration of B, concentration of A, concentration of A0 divided by concentration of B0 equals concentration of A0 minus concentration of B0 multiplied by KT. Half-life. It's at half, okay? Got it. You're talking about the version where concentrations are normalized to the. This is the normalized integrated second order law. The condition for using this formula. Uh, no side reaction, no reverse, no catalyst. Okay. Stoichiometric coefficients must be 1:1. Okay. That's What if stoichiometric coefficients are different? How is this equation gonna be changing? Initial concentration must be different, okay? Whether A greater than 0, okay? The equation is valid for either case, but you must keep the signs consistent. Mm-hmm. If the stochio the formula your tutor gave, assumptions, conditions for this formula, stoichiometric A is good. A plus B products. Uh, if this is not is what is one, then the rate law with 1 by v factor is integrated formula. You can just take simple ratio b by a. You have to integrate using explanation. The term accounts for how much p has been consumed for every a that reacts according to stoichiometrically practical consequences. There's no simple logarithmic formula like the one is one case. You can just solve it numerically by using approximations. Okay. Uh, TFCA by what is this? What is M? Mm-hmm. I'm still on the part A of the first question. Makes you question. Makes you wonder. Oh, you might be a bit stupid than normal people. I. You can. Okay. Exactly. That's the right intuition. Mm-hmm. But it's still VA by VB. Oh. So this is for the 1:1 ratio. So if they're different, it's gonna be okay. Can you write both the equation with the different coefficient for the second order rate law? Also explain what are the terms used. I'm a bit confused on M&M. If it's the reaction order, it would be second order reaction, right? Right? I'm not sure. I'm not sure. Bro, I got 15 minutes or something before my break. God damn it. I'm still on the first question. So slow. So fucking slow. How can I make it fast? Well, the first step was to eat. Yeah, of course. Eat something. Integrated form in terms of A, integrated form in terms of B. Special cases when this simplifies. Yeah, that's the normal one, right? Yeah, that's the normal one. Leads to logarithmic formula 1. Reactant is X's. Changes pseudo first order reaction, integrate only in the terms of A. Quick intuition on M and B. How strongly a reaction rate depends on A. How strongly. Well, the elemental reaction have absolutely. Let's break this down. Elementary reaction, a reaction that occurs in a single step with molecules colliding exactly as written. Stoichiometry, because it's elementary, the rate law is exactly determined by the stoichiometry. Single step collision, complex non-elementary reaction. A reaction occurs in multiple steps, possibly through intermediates. Overall, stoichiometric equation doesn't tell you how directly how the rate depends on each step. So, suppose the reaction occurs in two steps. A to X, fast equilibrium, X plus A plus B gives C, slow rate determining step. Experimental observation of rate law might give rate equals K. My battery's out, god damn it. Experimental observation of rate law might give m equals 1, VA not equal to VA equals 2, n equals 2 not. Overall, stoichiometry is not directly dictating the rate. The slowest step controls the kinetics, which can depend differently on A and B. So, elementary. Oh, there's no, okay. Complex. 0. What? So if the reaction happens in a single step, then it's with the coefficient same as m and n, same as rate order, right? If the reaction is complex, aka multiple step reaction, then the is not representing the actual rate order. Exactly, you got it perfectly. When ChatGPT says something like this, it just feels a bit, multiple steps, possibly through intermediates. Overall, stoichiometry does not tell you the reaction order. Okay, now could you explain the terms m and n like I understood that for complex reaction the rate order is different. Can you show me an example? Example of complex multiple step. No, I didn't get why you chose the m and n values. It's cold. Okay. Uh, Fast equilibrium, slow rate determining steps. Step 1, a molecule rapidly forms an intermediate X. X reacts with B to make the product. This is the slow step which controls the overall reaction rate. Okay. Step 2 controls the rate. The rate of the overall reaction is determined by the slow step, which is rate equals X. Okay. Suppose experimentally we find that it depends linearly on X and quadratically on B. Okay. Relating X to A, because X forms from A in fast equilibrium. 1A is 1X proportional. Substitute X to A into the rate law. Mm-hmm. So this part is what. So this is what determined the M and N values, basically. You know what, YouTube? I'm gonna end the stream. I will just cook my pizza really fast because I'm pretty hungry, and if I'm hungry, I can't focus. You know how it is. So I'm gonna end the stream, and not like last time. I'm gonna continue the stream. I'm gonna continue with biochemical kinetics for 1 more hour. Then I'll switch to sequence analysis because I have work tomorrow. YouTube. Peace. Let me go